Okay, so now what I want to look at is 2D, the second example, the one towards the bottom of the page. And for this one, I've got a calculator ready to go here because that's going to come in handy. And first, I'm going to clear that out so that you see all the steps that I'm going to do with the calculator. Okay, so the very first thing, find all the real zeros of that function. And we know from the rational zeros theorem how to at least get some candidates. So potential rational zeros. Those are going to be the factors of 8 over the factors of 2, the constant factors over the leading coefficient factors. So factors of 8 over factors of 2. So that's going to come out to positive negative 1, positive negative 2, positive negative 4, positive negative 8 over plus minus 1, plus minus 2. And then if I list those off, there's a lot of them here. So I could get 1, I could get 2, I could get 4, I could get 8 if I'm just dividing everything by that. Or I could get 1/2 if I divide by 2, the 1 by 2. I could get 2 over 2, which is just 1. That's already covered. 4 over 2 is 2, that's already covered. And 8 over 2 is 4, that's already covered. So there are 10 options to test there. And you could try testing them until you find the ones that work and find the ones that don't work, but that's going to take a long time. Maybe you come over to the side and just try 1, see if you get lucky, because 1's not that hard. 2, negative 7, negative 8, 14, 8. But I'll tell you right now, 1 doesn't work. And if you work it all out, I'm just going to fill it all in here. Let's see, negative 13, negative 13, 1, 1, 9. You end up with a remainder of 9, right? R equals 9. So x minus 1 doesn't factor into f of x. Well, you could keep trying, but there are going to be a lot of choices. There are 9 other choices to try. That takes too long, so what I want to do is use the graph to help. So over here, if I can get the graph to go on, I'm going to go to y equals and type in the function 2x to the fourth minus 7x to the third minus 8x squared plus 14x. Oh shoot, I gotta come back and change this. I hate doing that. I do that all the time. Okay, so that's a third. And then what is it? Minus 8x squared plus 14x and plus 8. Okay, so if I graph this in the standard window here, you're going to get a picture, but it's not entirely clear what exactly the function's doing. So to me, it looks like maybe if we zoom out to, or zoom in on the x-axis, x min is negative 3, we'll make it negative 4, and x max maybe like 7 or 8. And then I'll just zoom out a bit on the y. So let's go window, let's go negative 4 to I think 7 or 8. And then zoom out on the y, maybe negative 50 to 50 just to see how that looks. And so I'll make the scale on the y-axis 10. Okay, that looks pretty good. So I'm going to draw a picture of that graph over here. And let's see. So here's my picture of the graph. The y-axis, the x-axis. Kind of comes down, goes back up, crosses, goes down, goes back up. I want to include my window, so don't forget that on homework. I think it was, what was it, negative 5 or negative 4? I think it was negative 4 to 8 by negative 50 to 50. Let me double check that to make sure. Yeah, negative 4 to 8, 50 to 50, negative 50 to 50. Okay. Now, if you look at the graph, there are 1, 2, 3, 4 zeros on it. One there, one there, one there, one there. The one that, and remember, they don't all have to be rational. This theorem that we're using here, the rational zeros theorem, only gives us rational options. So maybe some of these are irrational. I don't know. But the one that probably looks like the best candidate right now to me is this one right here, because it looks like it goes right through 4. So I'm going to test 4 and see if that works. So if I plug in 4, right, this looks like 4. Okay, now you're not supposed to rely on your calculator to actually tell you that it's 4. And on a test, you're not going to get that. You might get the picture of the graph, but you're not going to get the calculator for a problem like this. So we're going to test x equals 4. Okay, so let's do that. Here's 4. I'm going to put in my function here. And if you do synthetic division on this, we're going to get 2 here, 8 here, 1 here, 4, negative 16, negative 2, negative 8, 0. Good. Remainder of 0. So that means x minus 4 factors evenly. So now I can write f of x as x minus 4 times 2x cubed plus x squared minus 4x minus 2. Okay, now I got this to deal with. So I wonder if I can factor that. Well, if I look back at this picture again, it looks to me like negative a half right there might be another good candidate to try. I can't try negative 3 halves or positive 3 halves because those aren't options that I have in my rational zeros theorem. But negative a half is one. So I'm going to try negative a half also. And instead of dividing it into the full thing that I had before, I'm just going to divide it into this. Because if negative a half works on the full thing, it's got to work in what's left over. So negative a half here, 2, 1, negative 4, negative 2. And if I work this out, let's see, I will bring down the 2. I get negative 1 here, so 0 there. Negative a half times 0 is 0. Negative 4, and then if I multiply those, I get 2 with the remainder of 0. So this is good too. So now I know negative a half works. So I can rewrite f of x as the first thing that I already had, x minus 4, the new factor that I have, which is x minus negative a half, so x plus 1 half, and what's left over, 2x squared minus 4. Okay, so then I can factor this even further. I can take out the 2. So now this turns into x minus 4, x plus a half, 2 on the outside, x squared minus 2, and then this I can factor as well. That's going to be x minus 4, x plus a half. Let me throw the 2 in front here. And x plus root 2, x minus root 2. So it turns out these other two zeros here weren't rational zeros. They're at root 2 and negative root 2. Okay, so the zeros, I think it asked for that too. The real zeros are going to be x equals plus and minus root 2 and 4 and negative a half. And here's the factored form for the polynomial. Okay, hope that helps.